Ellipses. The geometric definition of an ellipse says that an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points, F1 and F2, is a constant. These two fixed points are called the foci, which is just the plural of focus, of that ellipse. So basically, an ellipse is an oval-shaped graph. But where does that shape come from? Well, if you're given two fixed points, F1 and F2, if you choose a point on this so-called oval, if you take the distance from that point to F1, call that distance D1, and the distance from that point to F2, we'll call that D2, D1 plus D2 is always equal to the same number. It's always equal to some constant. So in other words, if I chose another point, let's say a point P right here, the distance from here to here plus the distance from here to here would be the same as well. It turns out the equation of an ellipse is x squared over a squared plus y squared over b squared is equal to 1, or it's x squared over b squared plus y squared over a squared equals 1. In either case, a is always larger than b, and a measures the distance from the center to the edge of the ellipse in the longer direction. And so when you have an ellipse, you will have sort of a longer piece of the ellipse and a shorter piece, so to speak. This longer segment here is called the major axis, and this shorter segment here is called the minor axis. And when the larger number is beneath the x, the ellipse is longer along the x-axis. If the larger number is beneath the y, now the longer axis, the major axis, is along the y-axis, and the shorter one, the minor axis, is along the x-axis. Now, in terms of the foci are located here and here inside of the ellipse, or here and here. And to locate the foci, you need the distance from the center to that point. And that distance is a number that we call c, and c is equal to a squared minus b squared in both cases. Let's go ahead and take a look at an example. So here I have the equation of an ellipse. I want to find the foci, the vertices, the lengths of the major and minor axes, and then I want to sketch the graph. Now, you can see that we already have the graph here, but let me explain where this comes from. So we can write this equation as x squared over 3 squared plus y squared over 2 squared is equal to 1. So in this case, a is equal to 3 and b is equal to 2. So this means the ellipse is going to be longer on the x-axis and shorter on the y-axis. And in fact, the distance from the center to the edge of the ellipse in this direction, we know is going to be 3. And the distance from the center to the ellipse in the other direction is going to be 2. That's the significance of the numbers a and b. Now, with those two numbers, we can actually sketch the graph of the ellipse. We just go 3 units to the right, 3 units to the left, 2 units up and 2 units down, and then we just draw this oval-shaped graph. Now, in terms of the vertices, these points here and here on the longer axis, those are called the vertices. So we can call this vertex 1 and we can call this vertex 2. Vertex 1 is clearly the point negative 3, 0, and vertex 2 is clearly the point positive 3, 0. Now, the length of the major axis is 6 units. You can see that it's 3 plus 3. And the length of the minor axis is 4 units. And you can see that right here, 2 plus 2 is 4. Now, the other thing we have to do is find the foci. Now, to get the foci, we need c, and c is always equal to the square root of a squared minus b squared. In this case, that's the square root of 3 squared minus 2 squared, which is the square root of 5. And that tells you the distance from the center to the focus. So that distance is radical 5 there, and also radical 5 there. So that means the coordinate of this focus is negative radical 5, 0, and the coordinate of this focus is positive radical 5, 0. Now, we already have the graph, but if you were to do this on a graphing calculator, keep in mind that you have to solve for y. So we have x squared over 9 plus y squared over 4 is equal to 1. Now, to solve for y, there's a couple of different ways to do it. I actually like to multiply both sides by 36 here. That's going to give us 4x squared plus 9y squared is equal to 36. Then we can subtract 4x squared from both sides to get this, and then divide by 9. So 36 minus 4x squared over 9. And then finally, we'll take the square root of both sides, and that's going to give us y equals plus or minus the square root of 36 minus 4x squared over 9. Now, you can do a little simplifying here. You can take the square root of the top and the bottom separately. And you can also factor a 4 out of the top, so you get 2 square root of 9 minus x squared, and then in the bottom, square root of 9 is 3. So you can write it like this. But it doesn't really matter if you use that or if you use this. But the point is, when you plug it into the graphing calculator, you have to enter 2 separate functions. One of them is going to give you the top half, and the other one is going to give you the bottom half. So here we have an ellipse in the other direction, so it is oblong in the y-axis direction. And here we just want to find the foci and then sketch the graph. So the first thing we need to do is write this equation in the format that it needs to be in. So we are supposed to have a 1 on the other side, so we're going to divide both sides by 144. Now 16 goes into 144 9 times. Therefore, 9 goes into 144 16 times. And this turns out to be x squared over 3 squared plus y squared over 4 squared is equal to 1. So to graph this is pretty simple. We know the center is at the origin. We know in the x direction, we're going to go 3 units to the right, 3 units to the left. In the y direction, we are going 4 units up and 4 units down. So once we get those 4 points, we can pretty easily graph the ellipse. And then for the focus, we need c. And remember, c is the square root of a squared minus b squared, which in this case is the square root of 4 squared minus 3 squared, which is the square root of 7. And so the distance from the center to the focus is radical 7 in both directions. So one focus is 0 radical 7, and the other focus is 0 negative radical 7. Here we have the vertices of an ellipse are negative 4, 0, and positive 4, 0. And the foci are negative 2, 0, and positive 2, 0. And we want to find its equation and sketch its graph. Now, to be fair, I already have the graph, which we wouldn't have, right? We need some other information here. But let's go ahead and write down what we know for sure. So we know that since the foci are along the x-axis, we know that A is the distance from here to here. So A is equal to 4. And we know that C is equal to 2 because the distance from the center to the focus is C. We just don't know the value of B. So we can find that because we know that C is equal to the square root of A squared minus B squared. So that's 2 equals the square root of 4 squared minus B squared. If we square both sides, we get 4 equals 16 minus B squared, or B squared is equal to 12, which means B is going to be 2 radical 3. So now that we know the value of B that allows us to graph this point and this point because that distance is going to be 2 radical 3. And of course, you could find the decimal equivalent of that. But then its equation we know is x squared over a squared plus y squared over b squared is equal to 1. And since we know that a is 4, it's going to be x squared over 16. And then b squared we know is 12, so y squared over 12 is equal to 1. And this is our equation. Next, we have a definition of something called eccentricity. Every ellipse has a number that they call E, which stands for eccentricity. And E is defined to be C divided by A. Now, this will always give you a number between 0 and 1, and it tells you about the shape of the ellipse. So the closer E is to 0, the more like a circle your ellipse is going to be. And the closer the eccentricity is to 1, the more oblong the ellipse is going to be. So if your eccentricity is very close to 0, your ellipse is going to look very much like a circle. And if your eccentricity is closer to 1, it's going to be a more oblong type of ellipse. So in the next example, we want to find the equation of an ellipse with foci at 0 plus or minus 8. So that would be this point here and this point here. And the eccentricity is 4 over 5. So because we know that the foci are 8 units above the origin, we know that C is equal to 8. And we also know that the eccentricity is C divided by A. So if the eccentricity is 4/5, and if C is equal to 8, this allows us to solve for A. And if we cross multiply, we can find that A must be 10. And then once we know that A is 10, we can find B by using the other formula. And if we square both sides here, we get 64 is equal to 100 minus B squared. So B squared is 36, which means B must be 6. So now we know, since A is 10, we know that these points must be 0, 10, and 0, negative 10. And then now we know that B is 6. These points must be 6, 0, and negative 6, 0. And there's the graph. And that concludes this video lesson.